The U.S. unemployment rate. Every month, the Bureau of Labor Statistics reports it to 2 decimal places. The number moves markets, changes Fed policy, shapes billions in investment decisions. And here is what almost nobody knows. That number is not the actual unemployment rate. It is a point estimate from a sample of 60,000 households with a confidence interval of plus or minus 0.2%. The most cited economic statistic in the world is built on the exact same formulas this exam will test you on. Central limit theorem, standard error, confidence intervals. The exam tests exactly one thing here. Do you understand what these numbers actually mean? The central limit theorem is the most important result in applied statistics. Here is what it says. No matter what the underlying population looks like, whether it is skewed, bimodal, uniform, or completely bizarre, if you take a large enough sample and compute the sample mean, that sample mean will follow an approximately normal distribution. The exam threshold is n greater than or equal to 30. This is not a coincidence. This is a mathematical guarantee. The common wrong answer on the exam. Candidates choose the answer that says the population must be normally distributed. That is the trap. The CLT is powerful precisely because it does not require the population to be normal. Normal comes out of the process, it does not need to go in. The standard error of the mean. This formula connects CLT to confidence intervals. SE equals sigma divided by the square root of n. When the population's standard deviation sigma is unknown, which is almost always, substitute the sample standard deviation s. SE equals s divided by the square root of n. Read this formula carefully. Sigma over root and not sigma over n. The square root is everything. If you double your sample size, your standard error does not halve. It shrinks by a factor of root 2, about 29%. To have the standard error, you must quadruple the sample size. The exam tests this square root relationship directly. Candidates who reason proportionally get it wrong every time. The confidence interval formula. Point estimate plus or minus the critical value times the standard error. Written out, x bar plus or minus z star times sigma over root n. 3 components, the point estimate x bar, the center. The critical value z star, determined by your confidence level. The standard error, determined by your sample size and variability. For 90% confidence, z equals 1.645. For 95%, z equals 1.96. For 99%, z equals 2.576. Memorize these 3 numbers. They appear in almost every confidence interval question on the exam. The margin of error is z star times the standard error, not z star times sigma. Compute the standard error first. This is the most common procedural error. The Z versus T decision. This is the single most tested decision rule in the entire quantitative methods section. Here is the exam trigger you need burned into memory. Is the population's standard deviation known? Yes, always use Z full stop. Sample size does not matter. Population standard deviation unknown. Now sample size determines your choice. N is 30 or greater. Z is acceptable by CFA curriculum convention. N is less than 30. You must use T, and the population must be normally distributed for T to be valid. Degrees of freedom for the T distribution, n-1. The exam will hand you a scenario where the population is normally distributed, variance is unknown, and n is 15. That answer is T with 14 degrees of freedom. Every time, Do not be distracted by the normal population. That justifies using t at small n, not z. Now the highest value trap on this entire reading. The confidence interval interpretation. Here is the wrong answer that appears on the CFA exam, and that several YouTube prep channels teach as correct. There is a 95% probability that the population mean falls within this interval. That is wrong. The population mean is a fixed constant. It either is or is not inside the interval you just computed. There is no probability to assign to a fixed number. The correct interpretation. If you were to draw many repeated samples and construct a confidence interval from each one, 95% of those intervals would contain the true population mean. The 95% refers to the reliability of the procedure, not to any specific interval. On the exam, immediately eliminate any answer containing the phrase, probability that the parameter lies within. That phrasing is always the wrong answer. 3 bias types, all 3 are directly tested. You will be given a scenario and asked to name the bias. 1 sentence per bias is all you need. Look-ahead bias, using information that was not available at the time the decision would have been made. The trigger phrase, timing mismatch. A backtest using January earnings data published in March, that is look-ahead bias. Survivorship bias, including only entities that survive to the end of the study period, excluding failures. The trigger phrase, excluded failures. Mutual fund databases that drop closed funds overstate returns. We only see the survivors. Data mining bias, searching through many variable combinations in the same dataset used to build the model, then reporting the best result as validated. The trigger phrase, searched many specifications. Butter production in Bangladesh predicting the S&P 500. Torture the data long enough and it will confess to anything. Time period bias rounds out the 4. The study window is too short or unrepresentative of the full market cycle. Exam question 1. According to the central limit theorem, the sampling distribution of the sample mean will be approximately normally distributed when A. The population from which samples are drawn is normally distributed. B. The sample size is sufficiently large, regardless of the population distribution. C. The population standard deviation is known. D. The sample is drawn using stratified random sampling. Take a moment. The answer is B. The CLT is specifically powerful because it eliminates the need for the population to be normal. Choice A is the classic trap. Choice C is irrelevant to CLT. Choice D describes a sampling method, not a CLT condition. Exam question 2. An analyst is constructing a confidence interval for a population mean. The population is normally distributed, but the population variance is unknown. The sample size is 15. Which distribution should be used? A. Standard normal Z distribution, because the population is normally distributed. B. Students' t-distribution with 14 degrees of freedom. C. Students' t-distribution with 15 degrees of freedom. D. Standard normal Z distribution, because the sample mean is normally distributed. The answer is B. Population variance unknown plus n less than 30 equals t required. Degrees of freedom equals n minus 1 equals 14. Choices A and D are the same trap restated. Normally distributed does not justify Z. The only trigger for Z is whether sigma is known. Choice C uses n instead of n minus 1 for degrees of freedom. Exam question 3. Which of the following statements regarding confidence intervals is most accurate? A. A 95% confidence interval means there is a 95% probability that the population mean falls within the interval. B. A A 95% confidence interval is constructed so that 95% of all such intervals built from repeated samples will contain the population mean. C. Increasing the confidence level from 95 to 99%, while holding sample size constant will narrow the interval. D. The confidence interval always contains the sample mean as its midpoint only when the population is normally distributed. The answer is B. Choice A is the number 1 exam trap. The parameter is fixed. You cannot assign it a probability. Choice C is backward. Higher confidence requires a larger z-value, which widens the interval. Choice D is wrong. The sample mean is always the midpoint regardless of population distribution. Exam question 4. An analyst collects a sample of 36 monthly fund returns with a sample mean of 1.5% and a sample standard deviation of 3.6%. The 90% confidence interval for the population mean monthly return is closest to A. 1.5% plus or minus 0.987%. B. 1.5% plus or minus 1.175%. C. 1.5% plus or minus 5.916%. D. 1.5% plus or minus 0.6%. The answer is A. Step 1. SE equals 3.6 over root 36 equals 0.6%. Step 2. 90% uses Z equals 1.645. Step 3. 1.645 times 0.6 equals 0.987%. Choice B uses Z equals 1.96, the 95% value. Choice C multiplies Z by raw standard deviation without the root n step, the most common procedural error. Choice D is the standard error alone, without multiplying by Z. Exam question 5. A researcher develops a trading strategy by examining 10 years of stock data and selecting the combination of technical indicators that produce the highest returns over that period. She reports this as a validated strategy. The most likely sampling bias is A. Survivorship bias. B. Look-ahead bias. C. Data mining bias. D. Time period bias. The answer is C. The trigger searched through many combinations in the same dataset used to develop the model and reported the best one. That is data mining. The strategy is fit to historical noise, not genuinely predictive. Survivorship requires excluded failures. Look-ahead requires a timing mismatch. Time period requires an unrepresentative window. None of those are described here. The cheat sheet. Pause here, screenshot this. Everything you need to answer any question on this reading, in one frame. Central limit theorem. N greater than or equal to 30 guarantees a normal sampling distribution regardless of population shape. Standard error, sigma over root n if sigma is known, s over root n if sigma is unknown. To have the standard error, quadruple n, not double it. Critical z-values, 90% equals 1.645, 95% equals 1.96, 99% equals 2.576. The z versus t rule. Sigma known always use z sigma unknown, and n less than 30 use t with degrees of freedom n-1. Confidence interval interpretation. The 95% refers to the procedure, not this specific interval. Eliminate any answer saying probability the parameter is in here. Width of CI, larger n narrows it, higher confidence widens it. 3 bias one-liners, look-ahead equals timing, survivorship equals excluded failures, data mining equals searched many specs. If this was on your exam tomorrow, here is exactly how you approach it. Quantitative methods is 8 to 12% of the CFA Level I exam, 14 to 21 questions. Sampling and estimation is a core reading within that weight. Time allocation. Confidence interval calculation questions, 90 seconds maximum. Bias identification, 60 seconds. Interpretation questions are pure recall, 30 seconds if you know the trap. 3 elimination rules that remove wrong answers instantly. On confidence interval interpretation, eliminate any answer containing the phrase probability that the parameter lies within. Always wrong. On Z versus T, eliminate any answer that cites population shape or sample mean distribution as the reason to use Z. The only trigger for Z is whether sigma is known. On CI width questions, translate the n change to a square root of n change. N times 4 means width divided by 2. N times 9 means width divided by 3. If you see population variance unknown and n less than 30 in the same stem, select t-distribution before reading the choices. 60,000. That is all it takes. 60,000 households, sampled carefully, to estimate the employment status of 330 million Americans, with a margin of error of 0.2%. The central limit theorem made that possible. The standard error quantified the uncertainty. The confidence interval communicated it honestly. These are not abstract exam formulas. They are the mathematics behind every economic statistic, every clinical trial result, every risk model at every major bank. The exam tests exactly one thing here. Do you know when to use Z versus T, how to build the interval, what it actually means, and which bias a flawed study is committing? If this was on your exam tomorrow, you would get it right. Next in quantitative methods, hypothesis testing.